Hello there. This next lesson is on the topic of equivalent dose rate. Now, in the last lesson, we talked about equivalent dose. So you should have had lots of time to make notes on equivalent dose. You will have done some problems from the problem booklet. You would have done the practice problems, worked examples in the course notes as well. And this lesson is going to be pretty much the same, except we're moving along to talk about something called equivalent dose rate. Here's the title. Once again, if you're going to stop your video, take a snapshot, cut it out, stick it in after printing it, then that's fine by me. Otherwise, I'll be telling you when we get to the bottom of each page, and you can pause if you need to catch up. Right, so here we go. So the only change really from equivalent dose to equivalent dose rate is we've added on this word rate, R-A-T-E, at the end. And what does that mean? Rate means how fast or how often is the equivalent dose received. And it's like getting letters in the post. You might get a letter every day, or you might get a letter every week. You might get only one letter coming through the post a year. And it's something to do with how often, how fast, how frequently does something happen. And this is exactly the same. It means how often do you receive something called the equivalent dose. And that's what the word rate means. Once again, if I write it down here, you need to copy it into your notes. So I think the thing to have a look at is to have a look at the practice question in the course notes. So you're obviously making these notes in your red jotter, but you've got your printed course notes. We'll have a look at practice question number 1, which is actually done for you on page 14. So if you don't have your course notes handy, you might want to pause the video now, go and find the course notes, because we're going to look at the question. Excuse me. So we found that a radiographer receives an equivalent dose of 600 microsieverts. So this is a question from the equivalent dose section. So we've already done this last time, and I said we'd be coming back to look at this, but we're adding this rate bit in. So we found that a radiographer receives an equivalent dose of 600 millisieverts. But is that like the post coming through the door? Is that every day? Is it every week, every month, or every year? So how often does this take place? Now, you can probably work this out yourself, that if you've got this 600 millisieverts every year, then that's in a year, that's 600 millisieverts, and spread out over a year, that might not be too bad. Actually it is, because we talked about what the rate should be for somebody, a member of the public, and it's about 2.2 millisieverts in a year. But if that radiographer was getting this every single day, over a year, that would be 600 lots of this multiplied by 365, and that's a huge amount of radiation. So this rate thing is is over what length of time period do you spread this equivalent dose. It's more dangerous to have this every single day than it might be to have this every year, for instance. So it's important that we know what time period we're talking about. Okay, so that's the end of the first page. I'll be rubbing that out. Pause if you need to get a screenshot, save it, print it out later. Now, no radiation's good, but it might be, and I'm going to say better. It's not really that much better, but it might be better to receive now, if you receive that in one day, that's going to be pretty serious, especially if you received it the next day and the next day. But if that 600 millisieverts was spread out over a year, you could work out how it's spread out. So what would that be? What would be the rate? So it's a one-off dose. The equivalent dose is 600 millisieverts. And if you receive it over a period of a year, then the equivalent dose rate is simply 600 millisieverts per year, written like that. Now, what would that be if you spread that out? You spread that out over the whole year. What would be the equivalent dose rate in a day? So you take your 600 millisieverts and you divide it into 365 chunks, and then you get your calculator out, which I'm going to do now. So I get my calculator out and I do 600 divided by 365 equals, and that comes out to be 1.64 millisieverts per day. Now, this time period could be anything. It could be in an hour, for instance. So you could divide that number by 24 and you'd know how much on average, what your dose rate was in an hour. You could do it per second. The time period can be any time period you like, but you usually just go with whatever the question says. You don't need to make up your own time period. You'll always be asked, what is this rate in a day, having got some information about what it is in a year. So if you took 1.64 one day, 1.64 the next day, 1.64 the next day, if you work 7 days a week, which is unlikely, completely for 365 days, you'd end up back with your 600 millisieverts in a complete year. So equivalent dose rate then is how often or how fast do you receive this over a period of time, and the time can be anything you like. Okay, now I'm going to continue with this pen. This pen's getting a bit broad and the writing's getting a bit smudged out. We'll see how this goes. I might need to go and get myself a new pen shortly. So our recommendation as members of the public, it's recommended that members of the public don't have more than 2.2 millisieverts in a year. And you need to remember this number. And remember, people like radiographers, physics teachers, they're allowed to receive a slightly higher dose rate because they're actually working with radioactivity. The only radioactivity you're going to be exposed to are all the ones that we talked about in background radiation. You shouldn't really come across any others unless you go for the occasional X-ray in hospital or the dentist, for instance. So for a member of the public, and I can't even remember if that recommended's got 2 M's or not. Doesn't look right. What's it look like with just 1 M? I don't know. That might be even worse. Perhaps I'll go back to 2. That doesn't make sense. For a member of the public, it is, yes, it does. It is recommended that you do not receive more than 2.2 millisieverts per year. So that is an equivalent dose rate. Anything with a period of time at the end, year, month, week, day, hour, second, whatever, anything with a time period is a equivalent dose rate. Okay, so you need to remember, that is something you need to remember, that in a year, you as a pupil would not be expected to receive any more than that. And they'll certainly ask you if you go for an X-ray, when did you last come for an X-ray? And they need to ensure that you don't get too much radiation to exceed that limit. That's a limit that's set in law. And if people exceed that, then the person who's controlling the radiation would be fined. Now, there's nobody controlling the amount of radiation that you get from background, but it can be controlled. So that's why a dentist or a radiographer in a hospital would ask you, and they've got to work out, if you've had so many X-rays in a year, are you exceeding that? And is there a reason? Is there a valid legal reason why you should exceed that? Because unless there is a valid legal reason, then the radiographers would get fined for exposing you to too much radiation, because they can control that. You can't control the amount of radiation you receive unless you live inside a completely airtight lead box, which doesn't happen. And we've talked about this before, that Highland Council has to make sure that you don't get more than that amount of radiation in a year. And that's why they go around checking the radiation levels in school. And if the radiation level in a school is too high, then they have to get rid of that radiation. And since most of the radiation inside buildings comes from what's called radon gas, which comes out of rocks that the school might be built on, then all that you need to do is open the windows or install some ventilation that makes sure the air containing that radioactive gas gets sucked out. And then they can go back, the council monitors can go back and they can measure the radiation again at any time throughout the year. And as long as the ventilation's working and air can get out of the room and fresh air can get in, because there'll be less outside. You don't want to get this gas concentrated in a room. There'll be less radiation outside, and bringing fresh air in will mean that that recommended dose of 2.2 millisieverts is not exceeded in a year. And they have to keep working away at this and testing and making sure that that rate is low enough. Okay, so what would that be in an average week? So in a week, what you've got to do is take that and simply divide it by 52, because there's 52 weeks in a year. So here's an example. So you're told we already get 2.2 millisieverts in a year. What would that be per week? So you do 2.2 divided by 52, and that is 0.423 millisieverts per week. And you want to keep your answers to 3 figures here. You don't want more than 3 figures. 3 is the recommended number of what's called significant figures. Now, something else that you might be asked, because that's quite simple, is just to find out what it is per week divided by 52, is what would that be? So this was example A. This is part B. I'm going to write equivalent dose rate like that, just to save writing it out again. You shouldn't abbreviate that if you're writing in an exam, but we're going to be writing it again and again this lesson. So what would this equivalent dose rate be? Not by changing the time, but I want to change this. And this is another common question that you could be asked, is what would this equivalent dose rate be in microsieverts per week? So I've not changed the time period, I've just changed the prefix. And you need to remember, there's lots of remembering here. There's that to remember. You need to remember that there are 1,000 microsieverts in a millisievert. That will not be given to you in any test. You've got to remember what these prefixes mean. So I'm just going to say, remember there's 1,000 microsieverts in a millisievert. So how do we change that? What we do is we multiply by 1,000 to change from millisieverts to microsieverts. And you can do that on your calculator, or if you're good at multiplying by tens and just moving the decimal place. So that gives you some examples of the sort of things that they can ask you to do. Change the rate from years into weeks or months or hours or whatever. You just got to think, how many hours are there in a day? How many hours in a week, how many weeks in a year, that sort of thing, which you'll carry around in your head. You need to be able to remember that anyway, but this is a little bit more physicsy. You need to remember how many microsieverts in a millisievert, which is 1,000, and you have to be able to do this conversion as well. Okay, that's the end of that board. That'll get rubbed out. And there'll be more of these later on, where you'll have to do this yourself, because you know that we always follow these lessons with you getting practice at problems, filling in problems on the course notes and doing questions from the problem booklet, the one with the big yellow and black sign. Right, now there is actually a formula that goes with this. And I'm going to introduce you to the formula. And the formula looks a bit weird. This is equivalent dose. We've already met equivalent dose in the last lesson. And we know that that is measured in sieverts because we've been doing sieverts all along here. This T on the bottom, this is your time, and the time could be in seconds, hours, weeks, years. You use the information that you're given in the question. So it's not a fixed period of time. So it could be seconds, weeks, could be months, could be years, could be hours, and you can really pick your own abbreviation for this. The only the one that you really need to know is S is definitely seconds, but weeks, or you can just write out week in full, or you can write out year in full, you can write out hour in full. Indeed, you can write out seconds. Okay, so equivalent dose divided by time. Now we've got this strange thing over here. This is pronounced H dot. So I'm going to write that down here. Because that's what it's got above it. That was good. My pen top falling off there. Pronounced H dot. And what does H dot stand for? It stands for the equivalent dose rate. And it will be in sieverts per week, or millisieverts per second, or microsieverts per hour. Just look at what the units that you're given and adapt the units for equivalent dose rate accordingly, and you'll always get the units in the question, whether it's sieverts, millisieverts, microsieverts, and whether it's seconds, weeks, hours, or whatever. You'll always get that given to you, and you've just got to do some sort of conversion, as we did in that last example, part A and part B. First one where we looked at rate changes in terms of time, and the second one where we looked at rate changes in terms of whether it was milli to micro. Okay, so in your course notes, I think this is in your course notes, there is actually a worked example on page 16, and we'll just have a look. So if you can open up your course notes, and it's on page 16 in your course notes, and it tells you that there are, it's worked out on the paper for you, but I just thought I'd go through this so you get an idea. It says that you get 120 microsieverts a working week. Now, I mentioned earlier, when you work out what this is, when you change it from the amount you get in a year to the amount you get in a day, and I said divide by 365, well, that assumes you're actually working 365 days in a year and you're receiving that dose every single day for a year. And that's highly unlikely. It's the same in a week. A week doesn't normally consist of 7 days. It's normally 5 days, and your day isn't a complete 24-hour day either. You probably go to work at 9 o'clock, you finish at 5 o'clock, for instance. So this question talks about a working week being from 9 to 5 and Monday to Friday. Now, using that information, it says what's the equivalent dose rate. This is the equivalent dose. This is the dose you get, but it wants to know what you get in a working week, and you've got to work out how many hours there are in that working week, because you're not there 24/7, you're not there 7 days a week. So 9 to 5, 9 o'clock till 5 o'clock is actually 9 till 5 is 8 hours, and Monday to Friday is 5 days. So for how long are you being exposed to that radiation when you're at work? Because it's a radiographer or somebody, and obviously when they come home, they're not receiving this, and they don't get that at night time when they're asleep. They only get this when they're actually at work. So to calculate what the equivalent dose rate is in a working week, we need to know how many hours in the working week, and there are 8 times 5. So we can now do the sum. I'm going to have to go on to the next board, but we know 8 times 5. 8 times 5 is 40. So I've got my formula. H dot is H over T. So H we've already got, which is 120 microsieverts. That's our dose, the total dose we've received in the week. The time period is 8 times 5, which is 40 hours. And so we can work out what the equivalent dose rate is. So the equivalent dose rate, H dot, is H over T. So we'll take H, which is 120. We'll divide that by 40. And that is 3 microsieverts per hour. There is another way of writing per hour that Mr. Garrod has used in his course notes, and he's used this notation. It's just exactly the same thing, microsieverts, and per hour he's written as H to the power of -1. I'm quite happy that you write per hour with the slash there, which means per, and then hour you can put as HR, or you can write as hour. It doesn't really matter. Okay, so that was how you get the information in the practice problem in the course notes, which is done for you. That's already complete for you. So there's no writing there to be done in the course notes, but you could have got that excuse me, you could have got that in your red jotter if you wanted it. Okay, so what we're now going to do is we're going to have a look at some of the other practice problems that are in the course notes on page 16. Okay, so we've got the average annual dose for a member of the public on page 16, number 1. Average annual dose for a member of the public is 2.2 microsieverts. You've got to remember that. We've already done that. So average, you've got this written in your course notes. Okay, average annual dose rate for a member of the public is 2.2 millisieverts. Okay, so that is in a year. Average annual. Annual means in 1 year. And that's a word that you should be aware of, that annual means in 1 year. And the question says, find the equivalent dose in microsieverts. Not in millisieverts, but in microsieverts. And we've done this already. This question's actually in 2 bits. It doesn't tell you to do it like this, but this is how you would do it. And then the second bit says, what's this equivalent dose rate in microsieverts per hour? So this is really just doing what we did before. So the second part is what's the equivalent dose rate in microsieverts per hour? So the question just does all this in 1 bit, but we're going to break it down into this first bit and into this second bit. I'll make that a number 1. I'll make that a number 2. This is part 1. That's part 2. So we've got in part 1, we know that H is 2.2 sieverts, and to convert that into microsieverts, we simply multiply by 1,000. Done this already. So that comes out to be 2,200 microsieverts. That's exactly the same number. It's just that here it's milli, here it's micro, and it just changes the size there. The second bit, finding out about what is the dose rate in microsieverts per hour. And this is in a year. So what you've got to do is work out how many hours in the year. Now, it's not like the radiographer who goes to work and is exposed from 9 till 5, Monday to Friday. You're exposed to radiation continually, whether you're awake, whether you're asleep. All this background radiation that you get, you're exposed to that all the time, and there's no getting away from it, as I said, unless you go and live in a lead-lined box. You're going to get that rate. So we don't need to think about, oh, is it only between the hours I'm in school, or is it only when I'm in a certain place? This you're going to get all the time from background radiation, from the food you eat, the water you drink, all of that radioactivity in the air from rocks, from nuclear tests, all that sort of thing. So we need to find out how many hours in the year. Well, we know in 1 year there are 365 days, and we know that every day has 24 hours, and so we can work out the number of hours. Every single hour of every day, of every week, every month, you are getting this radiation. So there are 8,760 hours. So what's this 2.2 millisieverts, which we've already changed to 2,200 microsieverts in a year? What is the rate in an hour? So here is our H dot equals H divided by T. I'm not going to do the little table because I've already got everything there. I know that my dose is 2,200, my equivalent dose, and I now need to divide that by the time period I've been given, which is hours, or you've worked that out. And so that works out, I've done this already, which is not using my calculator, that is equal to 0.251 microsieverts per hour. So it's really just going over everything we've done. So that's quite straightforward. Now, that's going to be it for this recorded lesson. What I now need you to do, and I'm going to put this into an assignment, I now need you to do the 2 other practice problems. There's 2 of them. That was question 1. You need to do question 2 and question 3, and they're on page 16 and 17 in your course notes. So these are course notes questions I need you to complete as part of your assignment. Then I'm going to ask you to do some problems from the problem booklet, and I'll put down in the assignment, I'll list the problems that I want you to do. Okay, that's been about half an hour, I think. So this should be fairly straightforward to do most of this. Watch the video, make your own notes as we go along, do some problems. It might take you an hour and a half for this, and this is your work this week. Obviously, from next week, you will be back in school at some stage. I don't know which days or which weeks, which lessons you're going to be coming to yet. The timetable for next week is still being worked on, but this will be your last bit of online work for this week, and something else will happen next week. If you're in school, you'll be in a lesson. If you're not in school, there will probably be more online stuff. I'm not sure how it's all going to work out. Timetables will be coming out to you sometime this week. So I'm going to stop that there. I shall go away now and write up the assignment, post all this up, in YouTube. Got to change it myself. That will take me a little bit of time. Change it from Google Meet into YouTube, upload the YouTube stuff, and put your assignment on. So hopefully, because I'm actually doing this on Wednesday morning, it's 9:15. Hopefully, I shall have all that done for the first class, which is at 10 o'clock, and that's 3F. It'll all be ready and done, hopefully, for Friday. But if this does not appear, well, you won't know if it doesn't appear, will you? If this doesn't appear at 10 o'clock, I'll have to put a little note up to say why it's not. Right, okay.